Hello everyone, welcome back to my story about deep learning and machine learning. Today I will introduce for you about the Topic Studio. This software is allow you can pre-process the data. Um, we can analyze the data sets and analyze the distribution and analyze, for example, the multi-label or value distribution. Or we can custom the analyzer and we can custom the transformation for argumentation and we can custom the dataset loader and we can choose the model to train to fit with the dataset and we can load another a model and this tool we can a little bit coding and focus on the training assemble model for survey or another target, you know. And for example, in there, in this demonstration, I will show you about how to using MNIST dataset and the model is MNIST classification. As you can see, in there we have some option. We can download dataset on the internet or we can log in offline dataset. And after that, we can import the dataset in here. Yes, and after import the dataset, we can you say the 100% of the dataset or how much what you can what you we need to fit for the model, and we can we can tuning the percentage of the training and validation of the data set, and we can choose the shuffle and the input of the data set is a tensor 0, or we can use the input target or the target, and the tensor 1 is the output is target, and the input is the bitmap or banding box or label or signal or spectrogram or the volume or another type of the data set, and label in here. It just can we can use the bitmap and we predict the bitmap. This bitmap is the data of the one label. This data set is the multi-class dataset, you know, and we can analyze the distribution of the multi-class. In here we can see that the distribution of the 10 class is equal, and we not have the imbalance dataset. It's either good dataset for training. And for example, in the 0 we have we have an we have we have 94% of the distribution. Yes, and after that, in the model we choose the multi-class sphere for this model, and in here we can choose a lot of type, for example detection, quantization, or segmentation, or model video of the talk vision, or or the talk audio, or another type of the model. In here, for example, we use the MNIST classifier to demo, and this model have 1 million and 200 parameters, 200,000 parameter. And in here we can custom the log function, because this is the classification uh, problem. So we use the cross entropy. If we have the two class, we use the binary cross entropy. And if we have a time series or the audio, we use the mean absolute error or mean square error, or smooth mean absolute error, or we can custom log in here. For example, the YOLO, we have the three logs for multitask learning. So in here we have the simple task, so we use the cross entropy. And the metric, we can use the recent recall, or the F1 score, or the accuracy, or we can custom the metric, for example F1 or F2 or another metric. And about the optimizer, we can use the ADAM, HJDs, or for example the ADAS, for example a lot of um, optimizer, so we can custom in here. And the scheduler, we can use the step or multi-step or one cycle, or the scheduler for model to learn fastly, and a model can converge. And about the path size, we can configure the path size to training model with more efficient and more fastly, And each page, we can configure each pole. And shuffle, we can use the shuffle chaining. This means after learn in the one epoch, we will shuffle the data and retrain. And we can choose the early stopping in here. For example, when the model hit the accuracy, or hit the condition, for example the mean error, mean absolute error, or mean square error, we can stop training in here. So we can in here for likely the Neutron software, we can see that this is the architecture of the model. As you can see, the conform the ReLU activation function, we use to conform maximum length and flatten the model, and linear in here. And after that, we activate with the log softmax function for prediction. And after that we have the output, and we can hear if we have the a lot of CPU in here, we can choose what the CPU we used for training. And after that we training. And after training, as you can see, that we can see it's either training either red line, and the variation either green line. As you can see, the loss is as you can see, the loss is not good, because the model is simply simplification. So we just to use the complex the model to solve this problem with more accuracy, and with more loss. As you can see, the validation and the training accuracy, it keep it 100%, for example maybe it 99%. As you can see in here, the accuracy is good, but the last is not good. Maybe the model is not complexity for fit with the data, so we just use another model to do it. As you can see about the prediction, for example, we can prediction the symbol one. Here we can see that very accuracy. Symbol 2, yes, very accuracy. We can test in here. The 1, just very accuracy. Yes. And after that, after training the model, we can export the model to the ONNX, or we can export the model to PyTorch model or another type of the model. And so about the dashboard, we can see that the dashboard uh, about the dashboard, we can see that we can training a lot of model in the same time, and we can survey that with the model is fit with the data, as you can see. Yes, and this is the tutorial today. Thank you for watching.